Hello, my name is Matthew. Welcome to 20 Games in 30 Days. In this series, I will be taking a look at some of the classic games throughout history and recreating them for myself. Without a tutorial, without assistance, my goal is to learn more about game design and become a better game designer myself in doing this. This is a kind of series that you can follow along with if you like. It is not a tutorial, but we'll look at some history and I will show how I make this game, including all my mistakes, so you can learn from those as well. I hope that you enjoy, and let's jump right in. We'll be starting out at the beginning with Pong. Now, Pong was not the first game ever created. However, it was one of the first games ever created. There are a few games before it. Most of them ran on very expensive hardware. Tennis for Two was actually created on a Cold War analog computer designed to plot missile trajectories. And so that one was a demo. It was essentially a table tennis game, precursor to Pong, but the output was on an oscilloscope, not a display, and it used this analog hardware that could calculate missile trajectories with wind, which is very interesting, but that's not a commercial game. After that, there was Space War, was another very early game. This one was on the PDP-1, a computer system that existed in early college technology departments. And so that was one that was quite popular with college students, but again, it just wasn't a mass market game. However, there are a couple guys, Nolan Bushnell and Ted Dabney, hopefully I'm pronouncing that right, who decided to turn Space War into an arcade game that they could manufacture themselves for a reasonable price. That game became Computer Space. It was the first ever arcade game, and it did all right. It didn't make them, mega millions. They didn't get famous, but it was a good enough game that it inspired them to form a company. That company was named Atari, and they hired their first engineer with the intention of creating a racing game to follow up Computer Space. Before they could create that racing game, they decided, you know what, this new guy, Alan Elkhorn, he is a skilled engineer, but he's never made a video game before. Most people hadn't back then, but that's beside the point. He's never made a video game, so let's task him with something simple. Bushnell said, hey, you know what, why don't you make us a game about ping pong? He did. He set out and he made this game where there was a ball, there was a player-controlled paddle on either side of the arena, and there was a score. So there's a score on either side, and this box represents the screen itself. And so that was it. That was the original Pong. They said, you know what, this was supposed to be a demo. Why don't we actually release this? They brought it down to a local tavern, and it was a smash hit. Everyone loved it. It actually stopped working. Brought Alcorn down to look at it, and he discovered the reason it was broken was because it was overflowing with quarters. They decided to start manufacturing this, and it became the first successful video game. It kickstarted the industry, huge legacy. So here is just what the game looks like, more or less. A couple interesting things about this game, actually. The paddles, they could move up and down. There was actually a bug in the hardware where they couldn't reach the top of the screen. All the way up, there was still a gap that the ball could go through. And so what that meant was that you couldn't play forever. You would eventually mess up. And that was something that Alcorn decided to keep in. Even though it was a bug, he decided, hey, it's a feature, and therefore it was a feature. So I'm going to get rid of these lines representing the bounds of the screen because we are going to be recreating this game in Godot. I'll talk about my engine choice a little later. But I'm going to be doing things a little bit differently. We're going to still be following the spirit of the original game, but we are going to actually be defining the top and bottom bounds. Just like he had that bug, which became a feature where the ball could go off the edges, we're going to actually define the arena as starting and ending not quite where the paddle reaches. So there'll be this gap here where the ball can go through. If you're good at aiming, you can get it through on your opponent's side. So even two perfectly skilled players would not go forever. Another interesting thing about this game, well, there are a couple things. One, so this is what it looked like. It had sound on it, which was kind of new for the time. So it had audio cues when the ball would bounce off the paddle or the top and bottom, or when it would go into the end zone. So for us, we'll define out here, there will be a space where when the ball enters this space, the opposite side scores. That's something we'll put in our version. But again, on the original, it was just when the ball left the screen. So we have a more or less faithful recreation now. We'll move these up and over. It'll look something like this when we create it. There'll be that dotted line representing the net. There'll be a top and bottom. And just for clear visual distinction, our screen would probably be somewhere around here. Ooh, that's an awful color. We'll change that to blue. Our screen will be somewhere around here. End zones will be outside of the screen. There'll be a gap here. Final thing about the original Pong is actually the paddles themselves. So if you've ever played Pong, the ball does not always bounce straight off the paddle. The way this was achieved in the original game is that it was actually broken into 8 segments. And each of those 8 segments would have a different angle of return. So for the middle couple segments, it was straight 90 degrees. But as you went farther out, the angles would increase more and more. So this is something we also want to replicate. And because we're using a modern game engine, we don't need to do it the same way that they did it. Here we go. This is the original Pong. So we're going to take this image now, and I'm going to open up Godot, and I already have an empty project here, and we are going to start turning this into an actual game. So we have a node 2D already. We're going to go ahead and add onto it. There are 3 kinds of bodies. We're going to want the static body for now. Kinematic body we'll be using later. This one's going to be, it's controllable by scripts. Rigid bodies are controlled by the physics engine. Static bodies don't move, but objects can interact with them. So that's the one we're going to select here. So we're going to go ahead and click that. Now we're going to go ahead and add here, we need a collision shape on top of that. We're going to add that on, and then we're also going to want a color rectangle, which those 3 things together will give us something you can see that the physics engine can interact with, and we can use that as a base for most of our components in this game. So we're going to use this base to make all 5 components actually, 2 paddles, a ball, and the walls. We will change it from a static body to something else depending on what we need, but for now we're going to put up the top wall, duplicate that, drag it to the bottom. I'll tidy these up later, and then we're going to make a 3rd one, and that's going to be the ball itself. So full disclosure, I am in VoiceOver right now. I thought that I could use a rigid body for the ball. So you'll see me setting that here. My idea was that the physics system could take care of the bouncing ball and the walls and the paddle and all that, and all I'd have to do is program the paddles to move up and down. It sounds great in theory. It turns out this cost me about an hour's worth of time, so I made that mistake here. I will probably fast forward some of the parts where I'm trying to figure out what's wrong with it, and I will explain later how I fixed this. So here's another small lesson learned. I discovered you can't actually scale a rigid body. So I'm just going to reset the scale here, and then we will start making the paddles. So we're going to duplicate the ball twice. We're going to call them player 1 and player 2. And then we're going to change that from a rigid body to a kinematic body. And then we're going to go ahead and move them to their 2 separate sides, change the size, and then we will be ready to hit play and see what happens next. Okay, almost forgot. We need to turn off gravity and give the ball an initial velocity. So we'll do those two things real quick, and then we'll hit play and we'll see if we have everything set up properly. And that is horrendously slow. So, a mistake I made was the velocity is set to 10, which you think, hey, if in Unity or something, 10 sounds like a great number. Godot, actually, though, it uses pixels as a unit of measurement. So, I believe that's 10 pixels per second, which is way too slow. So, we're going to try turning it up to something, maybe we'll try 800 and see if that works a little better. All right, so we got the ball to move, but it didn't bounce. I'm gonna go ahead and fast forward through this part. I add a physics material with a option called bounce that I can set to 1 that fixes that. The next issue, once that's fixed, is that the ball will bounce every which way. So you can change it actually to, it's called character mode, which does fix this problem, or at least appears to. It turns out that it doesn't entirely fix it. So this isn't a proper solution. It's just something that I thought would work. There's a lot of Googling, as you can tell during this part. But once I get to this point, I can move on to the character controller, and I have to come back and fix this a little bit later. So when I decided to make the character controller, I made another fairly large mistake. I noticed that there are a whole bunch of predefined commands up in here, the UI commands for Godot, and I thought I could clean up all those inputs and remove those and kind of trashed the whole project workspace and had to reset some things. So I cut that out. But I have, here's my completed script. It's pretty simple. It's just up and down for two separate players. So each one gets their own controls, keyboard versus WASD, and they can each move their paddle up and down at a fixed speed. So fairly simple and straightforward, but it works for moving the two paddles. I also have a variable, if you saw, for which player we are playing as. So I'm attaching the script to both controllers, setting this one to 2 instead of 1. And now we can move this one with arrow keys and this one with W and S. So we have that fixed. It looks like the ball is still bouncing funny. This is where we might need to figure out the physics system. Okay, I am back. Yeah, it has actually been a few hours. I went and took a walk and thought about things and wrote down and realized that my wonderful plan I had isn't quite going to work. So let's go back to here for a second. So, my original thought on this, we have these paddles. I assumed that everything would work perfectly well if I use a physics object. So I could just take this paddle and I could actually shape underneath the rigid body, or not the rigid body, the collider, which is invisible. I figured I could just kind of shape that like this, and it would give us that result with the ball bouncing off. But what I realized, as you saw when we're playing the game, is as the ball moves, or as the paddle moves up and down, if the paddle's moving when the ball hits it, it will cause the ball to move. And because the paddle is always moving at the same velocity, you're not going to be able to get any variety out of that. It's always going to send the ball in the same direction at the same speed, and that's boring. Second issue, this bouncing is coming from the fact that it is a kinematic body. So what's happening is this ball here, we'll zoom in on that. We've got this ball, right? But it's not actually a ball. or sorry. So we got this ball here, and it has a center point. And what's happening is as it's going and it's hitting the wall, the force is being applied here. And so what that should do, um, I guess it's a two-dimensional force. We'll just go like this. Sorry about my terrible arrows. So there we go. It's hitting the ball. It's going this way. What should happen is the ball moves, but because we have a more advanced physics engine than we really need, it's actually applying the torque as well to rotate the ball. And changing the mode did get rid of that torque vector, but what's happening is we're still losing the movement director or vector. This component being applied as torque just disappears. So there might be a way to fix that. But the easy solution that I already know how to do is just to control the ball just like we're controlling the paddles. So we'll track its velocity. We'll add its velocity in every step. It'll be a little bit fiddly, but it's going to give us a lot more control and fix all the issues. So that's just a small change from how I thought I was going to make this. Wow, we're still just working on Pong, and yet I already had a complete failure of what I thought I was going to do and had to try something new. So, real quick, I'm just going to, before we continue, I'm going to add some of the elements that we're going to want later. All right, I jumped back into voiceover mode. We're adding a black background here. And then I decided to throw in two labels as well for the score. These aren't working, they're just labels. So if you're following along, hopefully you know how to do that as well. I did have to download the font. It turns out Windows, I wanted to use the fixed system font that I had used on the Microsoft Paint picture as well, and I couldn't find it. So I spent a lot of time here, probably about a good 5 or so minutes trying to figure out how to download it. And once I downloaded that font, I got it set up, put it up on the two corners, and then I also added a dotted line for the net, which was just a bunch of visible rectangles. So once those things are all put together, then I actually am about to take a second detour into setting up end zones that work. Reason for that is it's really annoying when the game doesn't reset when you're debugging. So I'm going to finish those parts, and then I finally will fix this bug. So I ended up creating a couple extra nodes that I could store everything under. So now there's a UI node. There's also a court node that contains just a lot of these elements that we don't really need to touch. But the areas I'm about to create will go under that court node. So this is kind of important. And then ended up going through and changing all of the positions to actual numbers that I key in instead of just dragging the handles. So everything, by the time I'm done with this, will be perfectly square and will look a lot cleaner. Okay, so coming back from this detour to the other detour before we finally return to the main detour, and then we can finally finish this game. Um, yeah, oops. We are working on areas again. Okay, so we have a collision shape. We're going to do a rectangle. We have an area here. We're going to move that to behind the paddle. And what's going to happen is if we miss the ball with the paddle, it will get hit by or it'll enter this area, and that will tell us that we need to reset. So we're going to put this at 450 is half of 900. Oh, yes, this is centered. Should I center it on the game? That would make more sense. Actually, is that centered? That's not centered, is it? Nope. 475 is actually. Okay, so we go in. We now have areas. They don't do anything, but they're there. Next thing, we're going to attach a script to the game. We'll call it game script. That's fine. So when we enter the area, it's going to emit a signal. So if we go to the node and we have an area, nope, we want a body entered because this is a body, not an area. Body entered, edge left, body entered to game connect. Okay, I'm skipping ahead a little bit. Here is my first attempt at a game script. Quite simple, it takes the ball and it resets its position. The only problem with this script is that it doesn't work. Reason is the ball is still a rigid body, and rigid bodies don't respond to this kind of movement. You need to apply forces to them. So I went and looked at Kids Can Code. They had a great tutorial on the integrate forces function, which I thought I could use to overcome this. Remember, if I was just going to go and fix the bug and turn this into a kinematic body, this whole thing would be solved. So it's kind of funny. This is a moot point. But of course, I only can see that in hindsight. So here I am trying to integrate or use the integrate forces function, which I actually need to put this on the ball itself if I want it to move. But I'm putting this in the game. I'm scratching my head, wondering why can't I get this to move? This attempt didn't get very far. So I finally scrapped that and moved on to attempt number 3, which finally worked. So now we have our two functions that are attached to these signals coming out of those areas I have, and the two of them will both call the reset function, which will free the ball, which will remove it, and it'll create a new one from a prefab. So when the game starts, I now don't have a ball in the seam. It gets created right away and added here into this ball variable. And then that variable will be used to remove the ball. And as you can see, it's working. So it will, the ball go off the edge of the screen and it'll be deleted and it'll pop right back in. Sometimes. So I think at this point I decided to just finish all the little bits and pieces of the game. So I'm setting up here the score. We're going to store the score in a vector, because why not? And back to the part where I don't know exactly what I'm doing. I'm fast forwarding a long trip to the documentation. I am trying to format the string with 3 leading zeros. So I managed to figure it out here. It just takes a few more minutes. Five leading spaces for a total of 10. If integer starts with 0. Oh, got it. If this integer starts with 0. Ah, perfect. So we have scoring. Okay. That seems pretty good. We have worked scoring. We have players that move. Anything else we need? Sound. Yeah, let's do sound now. So, sound. I found freesound.org is great. I'll just let that go for a little while. Yeah. Let's see what blips and bloops sound great. So it was F sharp. So I'm thinking this one for bouncing off walls, and this one, wait, You got this one for walls and this one for the paddle, just to give a little bit of variety. So there we go. So we're just going to add 3 audio players now. So we're going to add this, and we're just going to call this sound, and we're just going to put all of these under here. So audio stream player is non-spatial, so that works just fine. Okay, so now we have all 3 sounds, and we're just going to throw in sound 1, sound 2, and the end sound. So now in here, when we miss, we're gonna sound miss dot play. And let's start with that. All right. Let's make sure that these playing autoplay. Back to voiceover it is then. So this one took a long time to track down. It turns out there is a bug in the current version of Godot that I am using. There is an open issue for this. It should be fixed in the future, but as of right now, if your track that you're using contains a repeat flag, as mine did, on the audio track itself, Godot will not import it in a way where you can autoplay it once. It will always repeat no matter what import settings you change, even if you tell it that this is a one-shot track, not a repeating track, doesn't matter. The solution is to go into Audacity or something similar and load up the track and then just export the track, and it'll clear that flag and it'll work. This is something that hopefully will be fixed in the future, but I managed to run into an engine bug in the Pong game, which is kind of hilarious. The good news is now that I have this bug that I can ignore, I will go fix the other bug that I've been ignoring for the past hour or so of recording. All right, well, we have the sounds we need. All right, things to do now. I think the main thing now, we have the game, we need to fix the bugs. And the main one is simply change by taking this. Where did the ball go? Oh, ball's a prefab now. This no longer can be a kinematic, or yeah, change type. This needs to be a kinematic body, not a rigid body. Which means if we go to play, it's not going to move. That's okay. Hello, I'm back. I'm thinking I'm going to switch to voiceover for the rest of this video. This is just getting really fiddly, so apologies to future me, but I'm turning the microphone off now. So just gonna listen to some music, get this done. It is 2 a.m. All right, we are back. This is actually about 2 weeks later. So I finished the game within 24 hours, as I'm trying to do for this challenge. But I thought it would make more sense to come back and show off my finished scripts than it would trying to voice over myself creating them. The ball script only took me about 15 minutes, but we're going to go back to the game script first. As I mentioned in the voiceover, I was able to fix the sound issue, so now we have all 3 working sounds. I'm going to go ahead and hit play. So here's the game. We got the paddle sound. We have a different sound for the top and bottom of the screen. And we have the final sound when someone scores. The other thing that I finished is you notice right now we are scoring on this player here. When he scores on the other side, the ball will then go off that end. So we can score in both directions, and it will start in the direction the player who served last will score next, or who scored last will serve next. So that was accomplished by calling a ball.flip here when we enter the left one. We are still creating a new ball every time. So we'll create the ball and then we'll tell it to change which direction it's going if it exited out of the left side. So that was just a kind of simple hack we did. I think everything else in this is what I've already showed. We have our 3 sounds now. Here's one. Oh, where are the next 2? Just kidding. Those ones are the ball plays them as it bounces. So here is our ball script. We have a start speed, which we had before, but now the ball contains that value. We have a paddle angle factor, which will be used to calculate what angle we bounce off the paddle. As I mentioned before, we're not moving based on the speed of the paddle, we're moving based on the distance from the center of the paddle. So this factor will help us figure that out. So when we create this, when we start, we give ourselves a start speed. If we flip, we change it to negative, which will turn us around. We're only using the X value. And then on the physics process event, we will do a move and slide, which will move the ball in its current direction at its current speed. These are kind of cool. I discovered these by, if you hold control and click, you'll go to the documentation. So I was reading through Kinematic Body 2D, had no idea these 3 functions exist, but they were exactly what I wanted. So we have an is on ceiling, an is on floor, and is on wall. And those will work because the paddles are walls and the ceiling and floor are represented by the top and bottom of the arena. And those are defined by giving it a normal vector. This tells you which direction is up. So we say up is up, and therefore the ceiling and floor are the top and bottom, and the wall is the paddle. So we don't need to check what we are running into. Normally you'd need to check is the other thing I'm running into is it tagged this? Is its name this? Does it have some ID? Here we can just say if it's a wall, if it's a floor. So that's kind of a cool little hack. So if we hit ceiling or floor, we just reverse the y speed. And because this velocity value is a variable that's always here, when we come around, we'll apply the new velocity next time. If it's on the wall, same thing. We'll just change it to its negative x direction. The thing that will change is we'll go through and we'll just check all the slides. There should only be one, but this will help us find our collider. So there should be one paddle. Ideally, you'd want to have some sort of error checking, but it's been fine so far. So hopefully it's okay and there's not a bug there. But we'll get the slide collision here, and then we will get the collider position y, and we'll subtract that from our position, and we'll multiply it by the paddle angle factor and put that back into the velocity. So that results in that behavior we have, where when you hit the center of the paddle, you bounce straight, but when you hit the edge of the paddle, you bounce off at an angle. And the sharper you hit, the sharper the angle. So if we hit just barely off center, we move a little. But if we hit way off center, we move quite a bit. And I played with that angle and speed a fair bit. So my final values here, if I go into the ball scene itself, we can see paddle angle factor is 15, start speed's 800. I thought I increased the speed, but maybe I didn't end up doing that. Nope, looks like I never increased the speed. When we hit a wall, we just negate it. For some reason, I thought that I had added a little bit, but I'm not. So we're sticking with 800 all the time. Yeah, I'm just double checking. Looks like we don't. Interesting. I really thought we did. But either way, here's the game script. I think I showed all this off. This is the same as it was before. paddle script is also the same. So really all I added with this ball script, it took about 15 minutes. It wasn't as bad as I made it out to be, and I kind of wasted a lot of time trying to avoid creating this script. So hey, lesson learned. Just go do the hard things. Usually you'll discover that you are more than capable of doing that, and it sometimes takes longer trying to pretend to be dumb instead of just letting yourself be smart and accomplish the thing you mean to accomplish. Final things I added. I did have a couple bugs where if you move the paddle all the way up, it'll travel off the edge of the screen because it's not hitting this white thing. So the way to fix that is I simply put in this was a collider here. So this is a static body. And I just changed the layer mask to match one of the layers. Here's the layer mask for the player. So the ball doesn't see it, but the player does. So the player's now boxed in, ball is not. The other issue I played against my wife, and she immediately found a bug. Every single time I make a game, even if I have tested it for an hour or 10 hours, it doesn't matter. She will always find a bug. And the bug she found was if you have it perfectly lined up where this is up here and the ball comes in and bounces off this edge, you can get it like here, in and up, and it can bounce back this way. So I added 2 extra areas here, which are copies of the previous area, and they just share this body entered signal. So we now have 6 areas instead of just 2. But yeah, that is the completed Pong. So we were almost there. It took me about an hour to make the game, an hour to get around to fixing this script, which took 15 minutes in the end, and another hour to fix the audio issue, which is hopefully going to be fixed at a later date. But if you run into that issue, now you know how to fix it yourself. All right. Well, thank you so much for watching. We will be back next week. I already finished this video. Finished the game, need to finish the video, but I made Breakout. So that will be up next. Thank you so much. All that's left here is some of my 3 a.m. mouth sounds as I was making Pong. Boop, boop. Okay. Next thing. That was handy. I did not know we could do that. I like it. Boop, 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 boop. That's fun. Let me just look at the import file here. Bit mono, mass, trim, normalize. Loop equals false. That's exactly what I want. So why is it looping? I think we just punt. I finished the game. I just need to add a couple audio streams. So first thing I'm going to do, I'm going to delete this. Save. Say, yeah, this doesn't exist anymore. So game is working without audio. Whoop, whoop. Now, if there's any penetration testers or speedrunners playing, they won't be able to break the game. They'll have to stay in bounds. We're gonna go autoplay. It's still going like that. All right, kids, don't do this at home. But it works, and it's good enough, and it means that our game is done. If this doesn't work, I'm gonna cry. Well, at least the rabbit hole goes deeper. I'll see what's happening here now. 16-bit disabled. It still doesn't change it, but it really, really should. Okay. Negative 800. That should have done it. Hey, all right. All right. And now we're done.